We must create loud, clean masters. That is the goal. That's what our job demands of us. So when I got this email challenging my methods, you can understand it's been impossible for me to move on. Mastering engineer Ian Stewart sent me this. Controlling rogue peaks upstream of other dynamics processing, digital or analog, is a fine idea. But with clipping, it warrants a little extra caution. The problem is that if there's any processing downstream that has phase shift, the clip section will no longer be on the peaks of the waveform, but rather somewhere on the side. This means you get the distortion of clipping without any of the peak level control benefits. Yuck. Now, I clipped first in my chain, so what Ian emailed me makes sense in theory, but am I in practice actually hurting myself from getting loud, clean masters? We need to check this out, so here are some tests we're going to look at. The first one, we're going to go aggressive, not practical. High pass filters before and after the clipper, and then measure peak values. The second thing is we're going to be a bit more practical. What was the EQ I actually used in this session? And have a look at the peak values of it being applied after the clipper. And then third, I want to see how my Dyne 1 multiband processor, how Diamond Saturator, how other phase-reliant processors actually shift the phase of peak values throughout the signal. Ultimately, I want to know if any changes in phase post-clipping are big enough to warrant an issue. So let's look at these values. So here is the raw mix, 5.3 decibel sample peak value. Then we go into the clipper where we've got a ceiling set at -5.6. This is the video where we go over the Soft Clip Pro and the Soft Clip transfer function. So that tangent function that creates it compresses 3 decibels from the top down to 1.5 decibels. So it creates a tangent curve where it takes each of those values and then processes it mathematically. And here's the video on that. So that was the video which caused Ian to email me about it. And that peak value is -5.6 because that's where that ceiling is, or -5.58, 5.6. So that's all good. That's just the clipping function operating as it should. Now let's get rid of the clipping function and add Pro Q3 before it. 40 hertz, -36 decibels per octave. Super aggressive, okay? This is super aggressive. And remember, to start off with, we've got an overall loudness of about 17.6, I think. Let that calculate. So our overall loudness is 19.3. We add the high pass filter and we don't have the clipper on. That peak value goes from 5.3 up to 5. And so we've lost 0.3 decibels of headroom. Okay, so using that high pass filter increases the peak value. Okay, what happens if we do that before the clipper is that the clipper ends up clipping 0.3 decibels more than it would have in the past, which is pretty negligent because I think those sample values, which it's actually doing, if I go to the loudest true peak here, which is 233 on the left-hand side, let's just do a little bit of analyzing here. This is really important. How much are we really? I think there'd be like 5 samples that we're clipping more. Well, there could be quite a few. So if we go the declipper here, where are we? Declip, declip, declip. If we go here and go to -5.6, where we were before, we're only ending up clipping an extra 3 or 4 samples in any 48,000 samples a second, 3-4 samples extra. Negligent to have the high pass filter before the clipper. But that's not what Ian's talking about. He's actually talking about what happens if we add the high pass filter after the clipper. What happens? This is really bad. This is really bad. Do not put high pass filters after a clipper. And I'll explain why. What ended up happening was we went from a clip signal, which is here, -5.6 decibel sample peak. Then we added the high pass filter afterwards and recorded the value. It actually went up to -3 decibels. Okay, now, am I ever going to use a high pass filter that aggressive at 40 hertz? Absolutely not. But this is demonstrating the most extreme of what he emailed me. 40 hertz, high pass filter, we lose 2.5 decibels of headroom and loudness. That is, period, not good. You do not want that when you're mastering because you're trying to create headroom, keep things dynamic, open it up. We've still got all the artifacts of the clipper. That's not good. But I'm never doing this. I think one thing to say is I'm never doing a high pass filter this aggressive. Something this has taught me, and we're still got other tests here to look at so we can learn more. But something this has taught me is if I am going to use a high pass filter, or I am going to use an aggressive phase shifting processor, which typically is a high pass filter because that's the most aggressive. You're doing a whole rotation in order to create that cut. That is going to have to sit before my clipper. Again, loud, clean masters. That's our aim. So, when I have to use a high pass filter, we're going to sit that before a clipper. But here's the reality of actually how I'm operating sessions. This here is the actual EQ move I did on the mastering session. Okay, a little bump in the top, a little bump up and down. Okay, a little peak and cut. Okay, how much did this change the peak value? Because this is what you're actually concerned about, is what you're actually doing in sessions. If you clip first and then you do an EQ change later, how much is that going to change the peak value of it, that you're actually negating what you had that clipper there for? So let's have a look at this. So this is the Sontec. It's going into the Sontec. Okay, this is going into the Sontec. We went from 5.6 to 5.5. Okay, for this EQ move here, that's the result. So I've lost 0.1 decibel of headroom. So this is completely negligible, absolutely negligible. But then I thought, that's not all I do in sessions. That was for this session specifically. Typically what I do is if I need to control the low end, I've either got a 1.5 dB boost or 1.5 dB cut, or 1 dB or half a dB, whatever it is. I've got this low shelf I like to use on the Sontec. I'm curious, is the phase shifting enough that the peak value is shifting enough that it's actually negating that clipper? And this is really interesting, because you've got to look into a smaller detail here, because you're going to see this low shelf, and it's actually brought the true peak level up. It's brought it up a whole decibel, okay? But this isn't bad, because what we also have to notice is the overall loudness. So if we go here, the clipper, negative 5.5, the integrated loudness is 7.3, okay? And it's 5.5. We add that boost to the low end. Where are we? Here we are. Here we are, the low shelf. We add that boost to the low end. And even though we've gained a whole decibel or 0.9 decibel of peak value, we've gained 0.9 decibel of integrated loudness. Okay, so if we bring it back down 0.9 decibels, we've made that EQ change, we've got the same peak value and we've got the same loudness, but we're able to change the tone. So it actually hasn't negated the effect of having that clipper there. We haven't changed those peak values so much so that we're not getting the benefit of clipping up front. I also thought, what happens if you do a cut? Is it going to do the same? Well, when you do a cut, it drops the peak value and the integrated loudness also drops as a result, but it's in relation to itself. It's 0.4 decibels down, integrated loudness 0.4 decibels down, and you can move up and back between that. So in the practical sense of that particular session where I'm using this EQ like this or like this post clip up, I'm not changing the peak value enough for it to warrant being an issue. And I thought, let's go down the rabbit hole of looking at all my other processes. So into Dyne 1. So through the Dyne 1 setup I had, the peak value was still negative 5.5, okay? Through the Diamond Saturator, in linear phase mode, I might add, was still 5.64, okay? So 5.64, 5.77, 5.64, 5.78. The phase interference from these isn't enough to throw that peak value out very far. Here's what we can extrapolate from this. So I think it's really important we learn lessons so then we can continue to improve what we're doing as mastering engineers, as people trying to master our records, make them sound the best, make them sound loud and clean and not compromised, is that clipping up front is very valid. And I think Ian flagging this in an email was exceptional, because I want to relay this message to you. It is a good technique, but we're going to be careful, because if you want to put a high pass filter, not that I do this, as in where's that high pass filter I was using? Here it is. Not that I do high pass filters this aggressive, but if you want to do something this aggressive, you need to do that before the clipper. Okay, so that's the first thing. Aggressive phase shifts before clipper. Post clipper, you just need to be conscious of how you're interfering with the phase relationship of things. You're doing a half a dB boost or a 1 dB boost, you're not going to be shifting the phase enough. If you're using a multi-band compressor and it's got good phase coherent crossovers, you're not going to be changing the peak value a whole lot. That's the lesson from this. That's louder, cleaner masters. I was stressed about this. I had to make this video, and you actually just watching me look at all that data in real time, because I'm like, I'm going to make this video. I'm just going to set up all the tests, print everything, throw it into Audio Editor, have a look. And that's where it's wound up. That's how the data sort of portrays it. This was way geekier. I like doing these little outros. This was a much geekier deep dive. It wasn't super practical, but it's really important information. It's a critical information. You need to explore these things. This might not be revolutionary in the way we master things. It's not going to change our sound greatly, but having this knowledge, having this application, having people question you. I love the fact that Ian emailed me this because it makes me go, wait, did I get something wrong? Have I done something wrong? I need to know. I need to look at empirical data here to see what supports this to be true, what supports it not to be true, how does it act in practice and improve. Boring video. I know, I'm so sorry it's boring video, but it's an important video. So I don't care that it might be a boring topic or a boring discussion. It helped me understand something better. It will help some people understand something better. So I'm going to do videos like this, as well as the fun ones. I've got fun ones. I always have fun ones, but this one, a bit boring, but let it be. All right. Until next time, take care.